We are delighted to see your continued enthusiasm and participation in this journey of continued learning and innovation. So today's workshop will provide participants with practical experience in IoT and embedded system development. This session will cover key areas such as ESP32 programming, sensing integration, communication protocols, real-time data visualization, and modern IoT development tools. And participants will also gain hands-on exposure to technologies such as MQTT for device communication, Node-RED for creating interactive dashboards, Wowski for simulating IoT projects, and GitHub for project collaboration and version control. By the end of this workshop, participants will gain a solid understanding of the IoT development workflow and learn how to build, simulate, and manage IoT applications for real-world scenarios. Without further delay, let us begin today's workshop. So now, it is my great pleasure to introduce our speaker for today's workshop, Mr. Rumesh Rajasegar, Research and Development Engineer at Sri Lanka Telecom PLC. Mr. Rumesh is a passionate engineer specializing in embedded systems, industrial IoT, and cloud-native technologies. He has extensive experience in designing end-to-end IoT solutions and working with the technologies such as ESP32, MQTT, AWS IoT, Node-RED, and GitHub-based collaborative developments. We are truly honored to have him with us this evening and look forward to learning a lot from his expertise and industry experience. Ladies and gentlemen, please join me in welcoming Mr. Rumesh Rajasegar. Mr. Rumesh, the virtual floor is now yours.
Hello, can you hear me?
Yes, Mr. Rumesh, you're audible.
Okay, my screen is visible, right?
Yes.
Okay, we will start. Okay. This workshop session going to be in two different sessions. Session one will be I'm fully focusing on embedded IoT node development. The second one will be visualization, dashboard creating, that kind of a thing. I think from the team, most of you know me. I'm Rumesh, working as R&D engineer at Sri Lanka Telecom. Okay, this is the contact planner. Session 1, I plan to cover the ESP32 embedded systems, mainly focusing on the ESP32 chips, give an intro about the IoT and the simulators and the firmware development, and the session 2 dashboards, mainly focusing on the Node-RED. Addition to that one, things board also there, and I plan to give some suggestion for the IoTrix this competition. Okay. I hope most of you are familiar with the basic electronics and embedded system microcontrollers. Docker and Docker Compose, not deep knowledge is not needed for this session, but we will explore that as well. Since this session is going time, you can interrupt me while I'm explaining the stuff. You can ask any doubt if you have any. That no need to be relevant to the subject I am explaining. If any additional thing also you can ask from me. Yeah. Okay, let's get started. I hope most of you know what is meant by the embedded system. This is a small brief overview of what is meant by the embedded systems. The word embedded, in the sense, kind of hidden. I hope it knows. For example, I will explain this one with one of the example. Let's say, for example, let's say you are traveling in a car or any vehicle. Suddenly, if any accident or something happens, at that time, automatically that airbag system should work. If you consider this full system, that airbag system, we can say that is one kind of embedded system in the vehicle. that has the hardware component and software components. Everything should be work on a precise timing. That is the most important part. Here we are only going to use a small microcontroller. Then in that one, operating system is going to be run. That is the idea. Another part in the embedded system, it also includes the microprocessor unit and microcontroller unit. Microcontroller is the one just now I explained. Microprocessor, it has the more power addition to the microcontroller. In this screen, you can see Arduino and the ESP32 and the Raspberry Pi. In this family, Arduino and the ESP32 is coming under the microcontroller unit, as a Raspberry Pi is falling under the single board computer. Yeah, so these are the kind of a comparison. You can see where this Arduino and the ESP32 has the limited capabilities. But if you consider the single board computer like a Raspberry Pi, that capabilities and functionalities are very high. Yeah, we will advance the slide. The same thing here. It's kind of a deep comparison here. Okay, let's take the memory. Usually for the microprocessor and the microcontroller, in the microcontroller that is going to be have the memory in the in chip. That is the idea. But nowadays, additionally also you can have the additional memory as well. Then peripherals, microcontroller that has the limited peripherals. Externally you need to connect. Then the clock speed, if you are considering microcontroller, is going to do the very specific tasks. Like we are calling as there are two terms there, general purpose computer and the special purpose computer. In microcontroller, it's going to perform only the very specific task in a high speed. That's the idea. And the power consumption in the device, microcontroller is going to draw very less power current over the voltage. That is for the microprocessor, it's kind of huge power. And the connectivity, microcontroller, it has the limited capacity capabilities, but additionally, we can add the kind of add-on modules. Then operating system in the device, both microprocessor and the microcontroller both can run on the operating system, but microcontroller, it has the limited capacity. Yeah, use case that will vary depend on the requirements. Yeah, in the cost wise, microcontroller going to be cheaper, but this is kind of a general comparison. Sometimes some microcontrollers are there that is more expensive than a single board computer. That is based on the purposes. For example, let's take in factory PLC systems are running. Let's say if you are going to deploy one kind of solution for their using a microcontroller, at that time, microcontroller cost can be very high compared to the microprocessor. Yeah. In embedded system, microcontroller or a microprocessor, mostly there are common communication protocols are there. You can see this is a sample visualization. For the comparison, I only took a 3, but there are many communication protocols are there. Let's take the I2C, inter-integrated circuit. That is an abbreviation for I2C. It's mainly used for the low-speed onboard communication. Let's say if you have in the motherboard, if you have the several peripherals, if you want to communicate between each other, this is the main protocol going to be used. Then other one is the SPI, serial peripheral interface. Here, I like to denote that one. This is serial communication, not a parallel. So in a serial means one with a time, only one bit is going to be transferred in a one line kind of a thing. I2C, it's going to be SDA and CL. CL in the sense clock, and SDA also there. If you take the SPI, it's going to be have more wires like clock, mostly in the sense master out, slave in kind of a thing. Like we can connect parallelly many devices. Mostly used for the memories and the sensors and LCDs. Even though sensors, there are wide range of the sensors are there. Some of the sensors coming with I2C, some of the things going with SPI, that varies. Master slave in the sense they're going to be one master and several slaves. Based on the slave address, master can address those slaves. Let's say if you're connected parallelly 5 sensors, that 5 sensors can be slave. So let's say if I want to read the sensor value, I can address the slave ID and I can read the address from that register, get into the master. That's the idea. For the UART, universal asynchronous receiver and transmitter, this also serial communication. Here only 2 pins, TX and RX. This is the connection. Like this also based on the sensors, modem terminal, that kind of thing. Usually, when we are using the let's say whatever the microcontroller, we are going to connect to our laptop using the USB cable kind of thing. At that time, we are mainly going to use the serial communication. That should be clear. These are the kind of a comparison between the protocols. Here you can see number of devices like UART, I2C, SPI, and the USB kind of a thing. We can like pair the devices as even though it's given like this, we can combine the things together. Let's say two USB interfaces are there, we can multiply this one as well. Yeah. Any doubt up to now? Anyone from the audience? Okay, let me know if I'm explaining a bit fast or if you want to slow down. It's okay. You can tell me. Yeah. Yeah. When we are taking the key building blocks of the embedded system, that is a kind of embedded system. Like it's kind of system integrated with the several modules. Let's take the earlier use case I told you that airbag system. In that one, you can see all these four units will be there. Let's take the data acquisition module. This is the one going to convert the physical signal into the digital one. Digital in the sense electrical. Okay, it that converting the physical in the sense physical can be distance, light, intensity, temperature, humidity, moisture, or whatever the thing. Ultimately, our microcontroller is going to read only the electrical signal, digital. That is this data acquisition module is going to do that part. Next, data processing module. This module is going to convert the read digital electrical signal in a meaningful way. For example, this is a kind of a raw signal. In this raw signal, we need to do kind of signal conditioning or noise cancelling, filtering, that kind of a thing. This data processing module is going to do that part. That is the whole idea. Then the communication module. Like when we are talking about the IoT, data acquisition is done, data processing also done. Then we need to transmit the data to the cloud or another platform. And where comes the communication module? There's another communication stuff is there that is between the sensors and the microprocessor. That is a different one. That's the one I explained earlier. This communication modules comes after processing the data. We are going to transmit to the cloud. At that time, we are going to have the communication module. It can be Wi-Fi, 4G, 5G, NB, IoT, LoRa, Zigbee, anything. It can. Then the power module, ultimately to power up the sensors and the embedded system or microcontroller or microprocessor, the power module will be there. Power module, industry standard one also there. Sometimes it needed to be designed the power module as well based on the requirement. Yeah. Uh, then gateway. This is the normal term. For example, okay, previous one I explained data acquisition module there, data processing module there, communication and power module. When we are combining this everything together as a bulk module, that is the one we are calling like a gateway. So we are going to connect the sensors to the gateway. Gateway going to process and do the signal processing or conditioning, and it's going to be transmitted the data through the cloud platform. That is the idea. This is kind of summarization of all the things I told from the beginning. I hope everything are clear. I'm not going too much into the theory part, but if you have any doubt, you can ask me. Yeah. Then up to now we saw some of the items earlier. Now sensors and actuators. Sensor in the sense is going to convert the physical characteristic into the electrical signal. Actuator in the sense that is other way around. For example, sensor I can tell temperature sensor, normal way DS, that normal sensor will be there, DS1, B2, B20, that sensor. Then actuator, we can tell motors, pump, that kind of way. It's going to do the actuating part. Like commonly we can tell input from the environment, output to the environment like that. Then the sensor and the actuator going to be integrated with the microcontroller unit or microprocessor unit. We call single board computer as well. After that, we are going to integrate all the things through the firmware or the coding. For the coding, mainly we can use the C++ or the Python. You can see this is a sample sketch for the Arduino to connect to the internet. Arduino IDE, we are using ESP32 connecting to the internet. That is a very simple sketch. If I'm decoding this code, this is the Wi-Fi SSID password. Here serial begin. As I mentioned earlier, we are using the serial protocol UART. So the debugging here we are setting the baud rate to communicate to sync both the things together. That's why we are setting the baud rate. Let's say sender and receiver talking at a different baud rate, we can't listen properly. That is the idea. This is another Python script running on the Jetson board or the Raspberry Pi. If I'm decoding this one, simply, okay, we will come to this part bit later. I will be covering this one later as a GPIO, general purpose input output. GPIO, it has the ESP32 as also has the ESP32 also has the GPIO, and the Raspberry Pi Jetson board also has the GPIO. We can set the GPIO high or low. If you see this part of the code, that's happening here. Okay. Then this one, it briefly explain about the variation, mainly on the ESP32 chips. I hope everyone know only the ESP32, but when we are considering in the market, ESP32 has the different variation. One is a SoC, system on chip. Second one is a module, another one is a dev kit. Mostly, or most of the people are using this dev kit that is kind of combined with the ESP32 module and the power and everything together, bundled together. So, okay, I will quickly explain about how you can select the ESP32 based on your project or need. Okay, I think everyone can see my screen. If you are going to ESP32 product selector in the Google, you can access to this website. Okay, my screen is visible, right? Google Chrome. Hello.
Yes, sir, you are visible.
Ah, okay, okay, okay. If you are going to the ESP32 product selector page, you can, okay, you can see this is the ESP32 official page that you need to denote. There are many pages are there. This is the official page where you can select the ESP32 chip module or dev kit based on your requirement. Okay, what are the requirements? Okay, I'm going to read. Okay, here you can see in the side, this side, Wi-Fi, Bluetooth, temperature, thread, like all the things are here this side. Say for one project, let's say you want to transmit the data through the Wi-Fi, ESP32 chip you are choosing, you should have the Wi-Fi. There are some misconception in the market. All the ESP32 chip has the Wi-Fi. There are some chips there which don't have the Wi-Fi module as well, only the processor. Even inside the Wi-Fi, you can choose what is the frequency you're going to transmit the data based on your requirement. You see, based on the that band, you need to select the correct power module as well. Okay. Then the Bluetooth. Bluetooth also different variation there. Based on the variation, you can select. For example, say if I'm choosing the in this side, you can see this is the all the chip. You see if I'm selecting the this one, automatically it's shorter. Based on that one, I can choose Bluetooth also there. Addition to that one, temperature. This is the working condition of the chip. Addition to this one, there are some ESP32 modules are there, dev kits are there that is coming with the temperature sensor itself. So let's say if you're going to develop some kind of IoT solution in the a different freezing area or something, cold temperature or something, for that one you need to select the temperature based on this one. Then the thread and the ZigBee. This is the newest addition to the thread is the new protocol introduced recently. So ESP32 can have the ZigBee and the thread as a, in the chip. Yeah, this is the SoC and module I explained earlier. You can see all the chips are there. The ESP32. We are generally in the term we are telling ESP32, but that has the many variation ESP32 P4, E22, H4, H2, like all the things you can see. But most commonly we are using this ESP32 by default. This is the one. Even in this one, internal memory, RAM and ROM, it can vary. So if you see 32E in 8 in the sense, this is the indication for the memory, static and the dynamic, that kind of a thing. Uh, if you see this one, ESP8266, this is we are calling like a node MCU. This is the oldest one in the family. There's another ESP chip called ESP01 that has the very limited GPIO pin. Let's say if you only want to connect one temperature sensor for the cost effective, you can use that one. It's more cheaper in the market. Even you can buy that one in the tronic.lk as well in Sri Lanka. Yeah. In the status, I would like to highlight this part. When you are developing some kind of a product, ultimately you're going to put into the market, you should think about the lifespan of that product. So let's say if you're manufacturing 100 devices now, in future you want to produce another 1,000. So you need to look into this status thing. Mass production should be available and EOL. I'll explain this with the slide. Yeah. Then core. ESP32 has the usually the one we are using that has the dual core, single core also there. In the dual core, one core is mostly used for the communication. Other one we are utilizing for the other GPIO communication. This one for the antenna, ESP32 inbuilt antenna also there. Additionally, also we can connect the antenna to make the coverage. This is more useful when we are going to deploy our gateway device inside the metal cage or metal box. Their connectivity issue can happen. So in that case, antenna should be outside the metal case. That's why this part. Then package number QFN is quadrature. Like when we are having the chip in the foreside that has the soldering pad. That is this package. Then memory. ESP32 internal static RAM, ROM, RTC. This according to our requirement we can customize. Let's say if you are going with the default ESP32 chip, we are not considering all the things. Let's say if you are going to develop one embedded system product specific to one need, you need to consider all of these things. See if you are only going to consume 500 KB or something, sometimes this will be overkill. So you need to reduce that one. Then the peripherals, ADC in the sense analog to digital converter, digital to analog, like all these things are there. I will brief this in upcoming slides. Up to now, are there any doubt on this selecting the ESP32 chip or module or anything? You can ask me. Otherwise, you can drop in a text as well. Any doubt, anyone? Okay. Okay. Go further. As I mentioned, EOL, end of life. When we are taking one ESP32 chip, definitely we need to consider end of life of that chip. For example, as I mentioned earlier, this ESP8266 Node MCU, that is the oldest in the family. From the manufacture date, this is the date they are giving for the that's lifespan. After this time, they will stop manufacturing the uh, devices, giving the updates on the library and everything. They say recently, if they found any security issues or anything for that chip or the firmware, they will not give the update. That is the meant by this end of life. Usually, it's like from the manufacturing, it will be like a 12 years. They will discontinue the chip. Basic support will be there, not additional things. No any new improvement kind of a thing. That's the idea. Okay. When you're selecting the ESP32 chip, as I mentioned earlier, we saw this thing in very detail in the ESP32 selector page. So the common ESP32 chip we are using, this is the spec. Okay. Okay. If you see this one, ESP32, I explain about the SOC module and the dev kit. You all know this is the ESP32 chip. I think if you broke this metal case, This is the inside that one, and it will be looking like this. This is the ESP32 chip. Like I explained earlier, quad-rated package, this is the four-side that soldering pad is there. So addition to that one, some let's say if you want to connect the GPIO to the external pins and everything, that signal modulation, conditioning, everything done here. Power module also inside this one. Okay. If you see the functional block diagram, as I mentioned earlier, ESP32 has the two cores. Here, these are the protocols that supports. Like SPI, we already saw what is meant by the SPI, I2C, I2S. These are the common things. Okay, I like to highlight this touch sensor. ESP32 already has one sensor. Let's say for you want to develop some product, let's say all the time you can search for the testing, you can search for the sensor. Simply for the testing, you can use this touch sensor. Let's say if you are going to touch one ESP32 pin, that is going to be detected you are touching or not. That is the this touch sensor. How this is working based on the ESD, we call let's say human hands has that static charges. When we are touching, it will be detected. So if you are interested, you can experiment on this touch sensor, inbuilt touch sensor in the ESP32 as well. Yeah. Addition to that one, Bluetooth chips, those things there, Wi-Fi is there, yeah, RF side is there, this one. This one, let's say if you want to, in the security measures, if you want to embed the security encryption, cryptography in the ESP32 itself, from someone cloning your firmware, you can use this feature. Firmware level you need to do, it also will be transferred to the hardware side as well. These are the things from them. I think this is clear. Okay. Mostly when you're selecting when you're going through the ESP32 chips and everything, I recommend, highly encourage you guys to go through the website official documentation and the manual data sheet. If you're going through this one, actually this is 78 pages. Most of the people are not like to read those things, but usually most of the information can be found here. If anything goes wrong, you can use this one to debug all the things. Let's say if you want to go in an advanced debugging thing, you can use the JTAG. This is the specialized one. Let's say if you are programming something, but you are not getting the expected result. In the market, many counterfeit ESP32 are there. So you want to check whether memory is corrupt or not corrupt, that kind of a thing. You need to connect your ESP32 chip to the external module. For that debugging, that this is really important. Yeah, I think we don't need to go into this more deep. If you're interested, you can go through. Okay. Then ESP32 SoC, the same one I explained earlier. Here, this part I didn't explain. Okay, here ESP32 has the several sleep modes. When we are considering about the power, ESP32 generally it's consume one power. When it's going to the sleep mode or hibernation mode, it's going to consume very less current in a microampere range. That is ideal. Fully functional in the sense, you can see the functional block diagram here. From that one, in the fully functional state, these are the components going to be active. At this time, this is the current going to be consumed. Mainly, I'm talking about the ESP32 common chip. It will vary on the different chip. That's why I didn't put the exact current here. If you are going to the modem sleep, at that time, Bluetooth and Wi-Fi going to be off. Other ESP32 chip, ULP coprocessor, RTC timer going to be active. Uh, Light sleep, ULP coprocessor and the RTC going to be active. Here also there are two modes there. I'll explain the what are the different things bit later. In the deep sleep mode, only going to RTC memory, RTC timer and RTC memory is going to be active. In a hibernation mode, only RTC timer is active. Okay, I will brief why we need this kind of sleep modes. When we are using the power supply, let's take the battery power. We are deploying one ESP32, one sensor connected, let's say human presence sensor or animal detection or some sensor is connected with the ESP32, that is battery power. Let's say if you're going to use the fully functional thing all the time, it's going to be consume the more power. At that time, since there is a battery power, to say when that is kind of event driven. No need to send the data all the time as well. When event is event driven in the sense, let's say some event is triggered, we need to send the data. At that time only, it should wake up all the sensor is activating the ESP32, then it's activating the modem, sending the data, going to the sleep. That kind of scenario. You can go deeper into the this all the sleep modes in official document from here. Yeah, ESP32 chip. You can see this is a typical ESP32 dev kit. Here, usually you're going to have the micro USB cable. It will be connected to your laptop and the EN button and the boot button. When you're uploading a code from your laptop to this one, some of the ESP32, you need to press the boot button to upload the code. Some of the time, you don't need to press the button. That based on the ESP32 chips. Then there's a one LED power LED. When you give the USB power, automatically this LED will be indicating. Usually it will be red color. Here there will be another LED not mentioned here. That is a connection LED kind of a thing. That also connected to another GPU. Let's say if it's connected to the internet, you can activate that another LED. Usually that is blue color. Then this is the USB to UART. We are using USB port here. Then we need to convert that into the serial one to communicate with the ESP32 chip. That is the this module is going to do. Then this is the one we talked earlier. All the description, everything are here. You can read. I will be providing the slides so you can read these things. Any questions up to now? If you don't like to talk, that's fine, but you can drop a message in the chat. That's it. Okay. Okay. Then I will move to the next slide. Okay. Everyone can see the screen, right?
Yes, Mr. Ramesh.
Okay. These text are visible, right? Is it very tiny?
Yeah,
No, right?
pretty much, yeah. They're visible.
Okay. 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 Thank you. Okay. If you're considering this ESP32 dev kit, uh, ultimately when you're selecting one microcontroller, you need to download the datasheet. This one we are calling like a pinout diagram. So you need to refer this diagram to connect whatever the sensor you are going to use. Basically, you are going to use one sensor that is supporting SPI protocol. So you need to search for the which pin you can use it from this ESP32 module. Okay. Okay. GPIO in the sense general purpose input output. Some of the pins only can be used as an input. Some of the pins can be used as a board. Input in the sense you are going to give the input to the ESP32 like the sensor. Output in the sense you are going to take the output from the ESP32 to do something. Just take the previous case sensors and the actuator. Let's say you want to read the data from the sensor, then you are going to use the input like input to that is the idea here. I think all the B5 here, as I explained earlier, these touch pins are there. You can see these are the touch sensors I explained earlier. Then to power it up, the ESP32, you can use the, okay, you can use this 3.3 power supply, or also you can use the V in pin as well. That also okay. Addition to that one, okay. Addition to that one, there are grounds are there. There are several grounds are there. All the grounds are connected together. Hold on. Okay, you can go through this one. Okay. I hope everyone knows about what is meant by the analog and the digital and the PWM thing. I hope everyone knows. Okay. Any doubt up to now? Hello. Okay. Okay. I will continue. Analog in the sense it's a continuous signal. Digital in the sense it's going to be 0, 1 kind of a thing. PWM, that is a kind of a special signal we are going to generate, like pulse width modulation. We are calling like a pulse width modulation technique. It's this technique is used to create analog like output using the digital pin. That's the idea. I think I will show the short demo for this case. What are the common application for this PWM? These are the common. Like let's say if I want to uh, do the motor control kind of a thing, I can't directly go into the high or directly low. At that time, I need to gradually adjust. That is the that one we can use the PWM signals. If you see this graph here, in the x-axis is the time, it's the voltage, y-axis. So we call duty cycle. This is a total time period for one cycle. So duty cycle is defined by the total time over the on time, t over t on over t, like kind of. So we can define this on time and the off time according to that one. In the firmware, we can change according to that one. We can get a different waveform like this. You see, duty cycle is 0 like this, 25 like this. Like we can change. Okay, I think I covered most of the parts on the embedded systems. Now we can move into the IoT. If any doubts up to now, you can ask me. Otherwise, we can have a short break for 5 minutes if really needed. Otherwise, I can continue. Okay, we will have around 2 minutes break. If any questions you want, you can ask. Dear everyone, there's a quiz will be there end of this session. I think if you have any doubts, you can ask me. I will open that quiz end of this IoT session one. You can answer the questions. So it will be really useful. We can check all the things will be from the same thing I am explaining from the start to end. Okay, let's start. I think hope everything are clear. Okay, up to now we only talked about the embedded system without the IoT. Some of the parts of it I covered about the IoT connectivity communication protocol as well. Now, as I properly go into the IoT side, okay, this is the definition. I hope everyone know about the meaning of the IoT, Internet of Things. This is the common definition for this one, but you can read for your knowledge. But I will summarize this one. Like in the world, there are many, like we have the devices, it can process locally data. After processing data, it can also give a meaningful output in the without the internet, like locally. You see, when we are connecting that one into the internet, anyone can access with the limited privileges or full privileges. They can do the actuator or they can only visualize what's really happening with that IoT device. So we can make like a more meaningful. That is the idea of this IoT. I think, okay, we'll go to the next. Okay, this is a little bit of the history. Okay, from the earlier days when there's no internet is there, suddenly when internet is coming at that time, there's no massive IoT devices are there. Only internet is there, also that is very restricted. Usage is very limited. By step, like we are in the current 2025 plus years. That is the period we are in. And this time, without IoT, now we are talking about kind of a thing called AI powered IoT, AIoT we are calling. Like I think in the previous session, they explained about the edge processing. Yeah, edge processing also there. Addition to that one, IoT part also there. That's the idea. Okay, here you can see that how it's evolving time by time. We are in here. It's with the time that IoT devices count. It's increasing massively. That is okay. Okay. Mainly, let's say if you are using a mobile phone, if you are using the pet tracking device or temperature monitoring device or smart watches or everything are coming under this IoT. I will tell you one thing, like let's say without IoT embedded system, like I can tell you the camera. Camera can be one of the embedded system. That is, we are going to use the camera only to take the photo or video. So that is kind of a very good example for the embedded system. You see, then IoT comes, we should be able to transmit that data, whatever they captured to the internet. So we should have the another module for the communication part. Yeah. Okay, same thing. Here we are calling like CPU, MCU, GPU. Yeah, there are all the things are there. So currently we are in the era AI-enabled cellular IoT module. As I mentioned, we can do the processing, then we can transmit the data. We can get the raw data from the sensor, then we can transmit to the cloud, then we can do the processing and visualize. Otherwise, we can get the data, sensor data there, we can do the signal conditioning there, then we can transmit the data. When the usages and the requirements are increasing, it's a bit difficult to address all the problems in a one microcontroller unit. That's why that single, sometimes we need a CPU and single board computer. Now GPU, like TPU, like it's increasing. There are some microcontrollers there which we can use to process locally. Let's say if I want to detect the traffic violation or something with a camera, I can integrate the microcontroller, not a microprocessor. I can use the microprocessor like Raspberry Pi as said. Even without the Raspberry Pi, I can use the microcontroller for the this processing part. Let's say if I am using the microcontroller, it's going to do only the tower logic. If you are taking the single board computer like Raspberry Pi, it's going to do many tasks at the same time. So we can optimize all the things if you are using the microcontrollers. I hope everything are clear. You can read the definitions later after I'm providing the slides. Okay. Here you can see IoT protocols. The protocols, there are different layers are there. One time I can tell RG45. One time I can tell MQTT. Like these are everything are coming under the IoT protocols in a different layers. As I mentioned, we are going to have the gateways or the controller. From the controller, let's say I'm going to connect the sensors, physical connectivity. Then comes the disk protocols. Like these things, some of the things I explained, like RS45, 485 or RS232 is a Modbus. SPI, you guys know, USB and the wireless. Wireless, okay, wireless I brief. Sometimes we can have the sensor with the wireless capable. So it can transmit the data from the sensor to the gateway through the wireless. Then if you are looking at the data link layer, these are the protocols. Like Zigbee also there, Wi-Fi, Bluetooth, everything are coming here. When we are coming to the transport layer, this IP4, these all the things are there. In the application protocol, we will cover page of the MQTT, HTTP bit later, but you can see in the data processing, these are coming in the cloud side, that application side. Okay, you can see this analytics use cases there. Let's say for this IoTrix competition, you are going to develop some solution. You can consider some of the use cases for this specific industries or requirements. Any doubts or anything you want to clarify from me? You can ask me anytime. You can interrupt me even when I'm asking, talking. Okay. Okay. Here in the application protocols, MQTT is there. Next, we are going to cover about the MQTT. When you're telling about the MQTT, message queuing, telemetry, transport, to understand how MQTT works, mostly these are the key terms you should be understanding. Like usually most of the software application they are using HTTP. MQTT it's like a protocol mainly designed and used for the IoT purposes. So I will explain how this MQTT works. When I'm covering this everything, you should be able to understand all the these terms. Okay, here we are going to have the sensor nodes or sensors with the gateway. Then it's going to transmit the data to the MQTT broker. This is in a kind of a cloud or different location. From the sensor to gateway, internet should be there. We are going to use the MQTT protocol. Then we are going to transmit the data to the MQTT broker. To transmit the data, we should have the topic and the payload. That is the message. One message contains the topic and the payload. Let's take the topic. Here topic is temperature and payload is like a 30. So it's a one message we are transmitting. Like here three messages are transmitted to the MQTT broker. MQTT broker is going to receive the message from the publisher. Since this is the one going to publish, we are calling this as a publisher. Publisher publish the topic and the message to the MQTT broker. Then whoever subscribe to the topic, they will receive the that message. That is the idea. So I think I covered the publisher subscribe. Okay, subscriber in the sense who is subscribed to the topic, we are calling subscriber. Okay. In the HTTP, there's one thing called handshaking. After sending the data from the server to the client or client to the server, we can have the kind of a confirmation message. In MQTT also, we are calling like a QoS, quality of service. There are three levels there. QoS 0, 1, 2. 0 in the sense fire and forget. So it's massively it's going to send the data continuously, but it's not making sure that edge device connected with the sensor is not making sure the data is received from the server side or whoever subscribed to the topic. In other way, MQTT QoS 2 in the sense it's going to acknowledge. It's going to wait for the acknowledgement from the server side or other devices. If that message is not received, it's going to retransmit. Then the birth message in the sense, let's say if device is going to go offline or online, when it's coming to online, it's going to send special message, I'm online. That is the birth message. Then last will testament in the sense, let's say device suddenly disconnecting or something, then we need to use the last will testament or last will message. Now I explained everything in a kind of theoretical way. Let's take one use case. In your home, you can have the smart switches or smart bulbs. So smart bulbs are there. Then you are going to send the signal from your mobile device or mobile application. You are going to turn on and turn off. At that time, you can think this scenario and you can identify all these things. Let's say due to some reason, suddenly there's no electricity in your home. At that time, you will be seeing the device is offline. Then let's say current is coming, then you will see device is online kind of thing. That is the this burst message and the last field testament. Also, addition to another thing, let's say bulb is working or switch is on. Let's say electricity is going and automatically it will be going into the off mode. When electricity is coming, current is coming, at that time again that bulb should be turned on, it should work in the normal last previous state. For that case also there's a one feature in the MQTT. You can search what is that feature. I'm not revealing all the things here. Okay. Then IoT introduction. This another part. Earlier we talked about the MQTT. Now we are talking about the HTTP or HTTPS. In the software domain, most of the people are using the HTTP protocol for the communication. This is kind of server and the client. There are several methods are there. Here I'm mainly focusing on the GET method and the POST method. We are going to have the web server, web browser. Usually it will be web browser. In our case, IoT devices. So we can send the request and get the response. That is the idea. Post also sending and getting that kind of a thing. I will show the live demo for these two cases. Yeah, I think we can move into the stop the theoretical part. We can. I hope everyone install the Arduino IDE. Can you guys raise me the hand who don't have the Arduino IDE in your laptop? I am expecting you to follow this one along with me, so you can also learn. You can experiment the same thing I am doing as well. You can send the direct message to me, or you can send some emoji in the chat, so I can make sure everyone install. Yeah, I can see the hands. I think most of the audience are from. I think I am guessing most of you are following me, but not replying, paying attention. If anything, you can talk to me. It's okay. Okay, I can see. Yeah, this is after lunchtime. I hope no one is sleeping, listening to me. Okay. Okay, yeah, I got some personal response as well. Okay, to address all the audience, I will be okay. Who have the Arduino ID set up in your laptop, you can follow along. Otherwise, okay, you can watch the video, watch this thing, and later you can try the stuff. Okay, okay. From the beginning, I covered what is meant by the embedded devices, embedded systems, and the microcontroller, single board computer, a little bit of the programming and sensor actuator, and intro to the IoT. Then let's say if I want to connect the microcontroller to our laptop and do some coding firmware development, then we need the IDE. Okay. Okay. IDE in the sense integrated development environment where we are going to use the one tool to upload the code to the microcontroller. Okay. Here, first, this is the kind of a code flow or debug flow everyone should understand. Let's say we are going to use the IDE and we are going to code and we are going to upload the code to the microcontroller. This is the workflow. Source code going to be in our laptop. That can be C code, MicroPython, or C++ or something. Then when you are compiling the, let's say when you are compiling the code, this is the process. Compiling to uploading to the microcontroller. Ultimately, this .bin file or X file will be flashed to the microcontroller. This libraries, all the things will be done from your laptop side. For the IDE, there are many platforms there. I am here only going to explain few things, Arduino IDE and the platform IO. But for the beginner, you can use the Arduino IDE. It's recommended. If you want kind of a more debugging, you can go with the platform IO or ESP IDF or Expressive IDE. Okay, to install the Arduino IDE, you can follow, you can go to this link and you can download and you can install. After installing, using one IDE, we can do many stuff. So we should configure our board. ESP32 board should work with this IDE. So we need to configure these things. All the all the information are here in a very detailed manner. You can follow along. Okay. Initial setup, you need to go to the file preference. You need to insert the URL of the board and automatically board manager will download all things. After that, let's say after connecting the your ESP32 to your laptop port, you need to select what is the port you are using for ESP32. Then it will be detected. Some of the time, automatically it will be detecting. Okay, let's take let's take this one. This is the Arduino IDE 2.3.6. The older version also there. Like initial thing after installing, you need to go this one preferences and you need to insert this board manager URL here. You see, if you have the multiple boards, you don't need to delete. You can additionally add into the same. That's possible. Once you type those things, automatically it will download. Then, if you are going to the boards, you can see here. You can see ESP. Since I only installed the ESP32, inside the ESP32 there are many variations there. You can select from here. Let's say if you are installing the Arduino, then you can see Arduino, Uno, Nano, those things. And this is the port. Now I did not connect any ESP32, still it's showing, but it will be not detected. Once you connect only, it will automatically detect. Then you can upload the code. Here, that is not there. That's right. Okay. Okay. I think I don't need to go. Okay. Here, this is the recent code. This is the board manager. Like here, you can search ESP32 and you can download. After inserting the URL, you can download from here. Then it will be detected. There are different things will be there. I highly recommend to go with the official. This ESP32 official board is this one. That's why I install this one. Also, I can go with this one as well. Then this is the library manager. Let's take this firmware. Here I'm using this library, PubSub client. This is the library used to transmit the data through the MQTT. So I will be searching. I will be installing from here. You see, this is installed, this is not installed. Here also you can select what is the version exactly you want. So you can go to the official page, you can read about the documentation and everything. In addition to that one, you can go with the examples. Okay, I will go with that one. This debug and searching. If you're going here, okay, these are the built-in examples, basics you can go through and you can study. Let's say after installing some of the libraries, if example folders are there, you can go through these things and you can study. Okay, I will take one example. Okay, let's take the PubSub client. Here, these are the examples. If I'm clicking the basic example, that will pop up the screen and that will show that sketch. Let me know all the things I'm explaining. If it's very basic, I can advance little bit to cover all the audience. I'm going little bit slow covering all the things. Yeah, this is the basic sketch. Here you can see how to send the data using the PubSub client library. So here Wi-Fi connection part is not there. This is only to check the PubSub. So connecting to the Wi-Fi, those codes you need to develop by yourself. I think you can go through and you can read. If you're unable to understand, you can go to the official that GitHub page of PubSub client and you can refer as well. Okay, this is the official PubSub client GitHub repo. Okay, earlier I briefly explained about the MQTT concept. This PubSub client, it's not supporting the QoS 2. These are the limitations. But most of the time when we are using, most of the people are using the PubSub client library. Like I mentioned earlier, QoS 0 means fire and forget. There's no confirmation of the messages received from the other side. That is, QoS is applicable for publish and subscribe as well. Also compatible hardware, everything you can go through. You see, while you're working on this library, if you encounter some bug or anything, you can also use this repo. You can give a fork and you can suggest some changes, and you can also give the pull request. Let's say if you want to develop the same library for QoS 2 or something, you can clone this one. You can give a pull request. If you find any other issues or something, you can create an issue. I hope you guys know about those things. Okay, back to this one. Okay, Arduino ID, I think I hope everything is clear. Okay, okay, okay. This is one thing I would like to mention. When you're writing the code, you should have the separate header files for the different configuration. You see here, I am assigning the pin for the different sensors. Here, there's another config.h file. This is header file where I'm including the Wi-Fi password and the MQTT, those credential, everything here. If you're having kind of a modular code for different cases, it will be really good for you to develop for future as well. But if you see this one, this code itself is going like a more than 400 lines. So at this time, it will be difficult to debug. If you're creating kind of a modular code base, it's really easy for you to debug. Yeah. Okay, back to the slides. Okay, this part is covered. Okay, this one. This is a sample blink code. Like in Arduino normal way, when we are coding void setup and the void loop, there are two functions. Void setup is going to be run only once. Void loop, it's going to be run forever. Let's say you have the LCD screen, dot matrix screen or something. You want to print something welcome message only when you turn on the device. After that, it only shows the sensor reading. So welcome message, you can use the void setup. All other sensor reading, you can use the void loop kind of a thing. Then digital write, you are going to write the digital write. This is a GPIO pin, and this is you are setting like a high, turn on the LED. You say if you are setting a low, LED will be turned off. Like this is a, for 1 second, you are turn on, turn off the LED. This is working code. For this code, you no need any additional libraries because Arduino already has the built-in libraries for this case. Let's take this one, peripheral management. Here GPIO, we can set the GPIO pin output to input. Here we are setting output. Like let's say we are setting the input, we can use that one as well. We can read. You can see digital pin read. I hope clear. Okay. After that, there's another one, platform IO. Okay. Okay. I am using the VS Code platform IO extension. I already installed, but let's say if you want to install, you can go to the VS Code and extension page. Then you can select the platform IO. It will take some time to initialize. Now all the modules are loading. Okay. While this one is loading, okay, now it's loaded. You can see from the platform IO. Okay, platform IO, these are the quick action and everything are there. Okay. After installing, by default, you will be seeing this screen. Platform IO home. This is the default screen you will be seeing. Okay. Here you can log in your account, but that is optional. Even without login, you can use the things. Okay, now I will quickly, okay, I will explain a few of these things. Like Arduino IDE, we are installing the libraries and everything. Here also, we can go and we can install the libraries the same way, but I will explain you few additional benefits of using this one instead of the Arduino IDE. Okay, let me open one project. It will be easy to explain. Okay, in the platform IO, now it's activating the extension and everything. Okay, the platform IO, there's one special file, platform IO.ini. Like we no need to go to the library one by one and we no need to install. Like this is the one variable we are using here. From this one, all the library installation, board management, everything can be done. Even in the framework, you say if I want to use the ESP IDF framework, simply I can update this one here, then I can use that one. So this is the additional benefits. Also, I can specifically mention the library version. Let's say if I want to update that also I can mention. So by using this one, you can transfer the code from one laptop to another laptop without depending on all the things. For example, when you're compiling this code, it will download all the libraries, everything automatically. You no need to do any manual stuff. Is it clear? Any doubt on that one? If any doubt, you can text me in the Zoom chat, or you can unmute and ask. Okay, this is the folder structure. Okay, this is the folder structure. When we are compiling the file, this .pio file, this is the compiled files. This is nothing to do with the original source code. You see, when you are transferring the file from this laptop to another laptop or your friend or something, you no need to send these files. You can delete this one. These are the build files. Addition to that one, these are the, by default, it will create a folder structure. If you want specifically, you can also create a kind of a folder structure inside this one. But ultimately, this SRC, this is a source file. Here, you should have the main CPP. In the main CPP, you can have your source code. But let's take your Arduino IDE. Here, this extension is .ino. This also you are writing the C++. But here that it will not strictly check for the C++ structure and other stuff. It will check, but not that much strict. But when we are taking the platform IO, it will seriously check all the principles and everything. So that's why it's good practice to use this CPP mainly with the platform IO. Yeah, I think it's clear. Then let's say if I want to upload this code to the testing, okay. In the Arduino IDE, without the laptop, I can compile the code. Let's say if I'm compiling the code, it will show the output. If any errors or anything, it will show. At the moment, I didn't select the board. That's why missing this error is there. First, I need to select the board. Here, since I did not connect any port or anything, I can't select the board. Okay. Let's say if I'm selecting here, already in the platform IO.ini file, all the board, everything I have. This is the one environment I'm using for this code. I can have the several environment. Let's say I have the ESP32 mini, S3 or different board. I can have the different environment variable. So I can activate, deactivate, that kind of thing I can do. So you can see in the downside, in this window, you can see, let's say if I want to build this code, simply I will be pressing and it will be running this command. Then it's building locally. If any errors or anything there, it will show. Let's say if dependency, these libraries are not available, it will automatically download and it will compile. Like these are the compiled files, those are inside this folder. Here you can see these are the errors. If anything very strict errors are there, it will automatically terminate the session. Okay, this is clear, I guess. Then let's say if you are printing something, let's go to the code. Okay, in this code, I'm printing something. To see what is printing in the serial printer, we can use the serial monitor here. After connecting to the ESP32, we can check it. In the Arduino IDE also same thing available here, this serial monitor. Since I did not connect, I can't see here. Addition to the serial monitor, let's say if you want to print all the serial monitor thing to IO, you can write to the one log file. So later you can use that one for the debugging. That's it. And let's say if you want to clean all the build file, everything, you can use this clean one and test there and serial monitor there. Like this thing, IO, it's clear. Also, there's another, let's say if you want additional extra serial monitor, you can use another software called Coolter. This is that software. Okay, here you can see successfully compiled. You can see all the RAM, ROM, every usage, everything you can see. There's no any errors in the compiling and everything. Next, you can upload this code to the ESP32. Okay, this is the another software where you can use this one to debug the serial communication between your ESP32 or any microcontroller to your laptop. Since not connected, I can't see. This has kind of an additional few options configuration you can do. Now it's not connected, disconnect. That's right. You can't see. Yeah, I think okay. Let's move back to the slide. Okay. To install the platform IO, you can follow this one. You can go to this dock and you can download and install. After that, these all the things I pretty much explained the things. Moving to the next. Okay, let's say if you want to do kind of additional debugging thing, after uploading the code to the ESP32, you want to see your variable, specific variable saved in which memory location. So that also you can do with the platform IO ID itself. Additionally, you need to connect another hardware with the ESP32. That's also additional thing you need to do. This is for kind of advanced debugging. Let's say this is a memory layout in C. So let's say if you want to see what's really happening inside the ESP32 memory, you can use. Say memory is increasing, decreasing, value is saved where, what is the size, everything you can use. You can use the platform IO for advanced debugging as well. Here, one thing I like to mention, here I'm everything running graphically through the VS Code extension. If you are installing the platform IO without the VS Code extension, you can run the commands. Like here I'm running, since I'm compiling, here I'm running this command. So simply PIO run will do all the stuff rather than this. Yeah, I hope everything are clear. Okay, for time being, I will stop the Arduino ID and this is the IDF interface. IDF coming with the IDF is a kind of a framework. We can use the ESP ID for this coding part. These are the brief. Then we can move into the simulation. Okay, tell me, sidebar is visible? I'm not sure. The start button is there. Is it visible? This walkway and other stuff in the slides?
So your slide is visible. Other than that, nothing is visible.
Okay, okay. Yeah, I'm sharing the slide. Okay. Okay, let's go. Okay. Okay. Yeah, I brief about the sensors and the actuators for the simple demo. Since we don't have the physical devices all the time, we can't search for the physical devices. Or let's say even without the ESP32, you want to experiment few stuff. There comes the simulator part. That has the limited capacities, but you can explore that part, get the understanding of the microcontroller programming and other side. Simulators, mainly walkway simulator there. That has the two window. This side is a coding side. This side is a kind of simulation, physical hardware. You can see. Addition to that one, already created projects are there. Feature projects. So you can go click these projects and you can see what's really happening without modifying anything. After that, you can create your own project. You can experiment the stuff. There's another platform called Proteus. You can use that one also, but Walkway Simulator is a browser based. It's free. There's a limitation there for the running time and other stuff, but it's free. But for the Proteus, you need to install locally. You need to use the good version. So you need to get paid. You need to pay for those. Okay. I added some of the examples here. So okay, we will check a few things here. Okay. this is the very basic sketch. As I mentioned, this side is a coding side, this side is a hardware with simulation. Here, what we are going to do is here GPU pin definition is there 4 and 14. But if you see here, D14 is there, D4 is there. There are two LEDs connected to those pins. Those are the definition here. After that, I'm setting the serial begin for see the serial pin statement in the screen. Then I'm setting the pin mode to output. That is the part, both of the pins. Then in the void loop, I'm setting the digital write high for those two and putting a delay for 1 second and turn off the lights. That's the part. Okay, I will run the simulation. This is the serial train. Let's say if you're using the IDE and uploading the code, the same similar kind of a thing you will see. Now you can see this blink is blinking. Every 1 second it's blinking. Okay. Even though I'm using the serial begin here, actually I'm not utilizing this one. I'm not printing anything. That's why there's no any print statement there. Let's say if I'm adding the serial print something, it will be displaying here. Okay, I will stop this one. Okay. Okay. If you're going to the home page, as I mentioned, different microcontroller there. You can select what is the microcontroller you're going to use, and different projects will be also there. Like these are the featured projects. So, example, just take this one. Here, you don't need to do anything. Just you need to study the code and run the simulation. It will work. Here, this is the LED. You can see. Okay. I think from the audience, any one of you can tell what is the protocol this display is using. You can send in the chat. It's okay. Otherwise, unmute and you can speak. This display. You can see SCL is there, SDA is there. In the beginning of this session, we started. It was in the slides. Okay, answer is in the screen. Any of you can identify? Okay. Okay, I'm waiting for the answers. You can reply. I got few answers. Yeah. If you don't like to send in a comment chat, you can privately text me as a the direct message. Okay, yeah, I got few answers. Yeah, correct. Yeah, I got few correct answers. Okay, yeah, answer is I2C. I2C is the answer. Okay. This is the previous one, not a previous one. Okay. Earlier we saw about the simple sketch, this first sketch. This is the different sketch. Here it's going to blink in a different frequency. Okay, let me open this one. Let me play this one. Okay. Here you can see both are blinking in a different frequency. For that one, I'm using the millis function where code is not stopped. All the time I'm tracking the time. Every time I'm checking whether the time is passed or not. According to that one, I'm blinking the LED. Yeah. The same thing, same scenario we can use with the different methods. Yeah, those are these things. In your free time, you can go through those things. Yeah, this is a basic sketch to connect to the Wi-Fi. Simply, I'm including the Wi-Fi.h. That this is a built-in library. You don't need to install anything. Entering the username and the password. Here, with setup. Only I'm starting the Wi-Fi connectivity. That searching for this one and SSID and the password that is there. After passing, if it's connected, it will print until connecting. It will print connecting. After connected, it will print connected to Wi-Fi. This is in the void set. In the void loop, nothing is there. For this kind of scenario, for example, first you need to connect to the Wi-Fi, then you need to get the sensor data and transmit. So that's why void setup mostly we are putting this on. We can add the handlers and many things we can do. This is very basic. Then other one at this side you can see here is connected to the Wi-Fi, then it's started sending the data. Here this Wi-Fi addition to the Wi-Fi.h pops up client library I install and I am doing the configuration for the MQTT server and the topic and the port, everything I need to define. That part is done here, connected. Okay. Here I didn't mention the port of the MQTT broker, but here I am defining. It's connected to the Wi-Fi and topic also there and it's sending the data. Yeah, I think every 2 seconds I'm sending. Yeah. Okay. This one blocking and non-blocking concept. When we are putting the delays, that time nothing will happen. It will wait, kind of sleep kind of a thing. Nothing will happen during this time. But when we are using the millis, that function, it will track the time. So it will be not sleep all the time. It will be tracking. So in a same time, we can do parallel task kind of thing. So it will be not blocked. Yeah. Then real-time operating system. The very beginning of starting, I told you microcontroller, microprocessor, both can run the operating systems. But microcontroller that has the limited capabilities, so real-time operating system, RTOS, will be running there. Yeah, this one is resource constrained operating system built for the real time. Like I explained, like an earlier use case, that airbag system kind of a thing. So I will, yeah. Okay. Okay. In this code, we are connecting to the internet, sending the data to the MQTT broker. After sending to the MQTT broker, we need to make sure we need to visualize the data. So next coming the visualization part. At that time, we don't have the cloud dashboard and other stuff. So visualize that one. There's a one thing called MQTT client. There are many client software there. Here I'm mainly explaining the MQTT Explorer. So this is the startup page and everything. You can configure your broker URL, port, topic, and everything. Once you configure, when the ESP32 H device sending data, you can see the visualization from this windows. Okay. This is the MQTT Explorer window. I put a screenshot. Here you can see this HiveMQ is a one free MQTT broker, and the test mosquito, another three. This one. Here, when I'm going to the advanced, here I can configure the topics. Here I can mention the QoS as well. Let's say if I'm going with a different configuration for MQTT, I can include the certificate as well. Okay, now I am trying to connect. Now I am connected. For the connected topic, there's no data is coming. That's why here nothing is showing. So simply demonstrate that part also. I will use one of the topic here. Topic slash one. Okay, I can use this topic. Okay, if you see this side, this is a publish window. For the publishing, I can put a topic. I can select what is the format I am going to send, and I can type the message I am going to send. This is a publish window. This side, whatever the subscribe the things, it will be showing here. So I'm going to publish from here. Subscribe will be coming here. You can see. Just now I published. Then this is the one I topic one IoTrix. So it's coming here. You see, if I'm continuously sending some center day or something, automatically it will be updating, and history also I can see. I can plot seeing I can see the plot as well. Okay. Addition to the MQTT Explorer, there's another software called MQTT Box. This also we can configure, like let's take mosquito. Yeah, I already configured. You see, if I here there's some kind of advanced thing also there, but MQTT Explorer those are not there. So for advanced debugging and everything, you can use this one, but it will be same. Most of the things are. Yeah. I think hope everything are clear. We will have around 5 minutes break. After that, there is a quiz is there. Looking forward to see that one. Yeah, we will see. We will have a 5 minutes break. 4:15 we will join. In the meantime, I will share the quiz joining thing. I will not start the quiz. You can join. After that, you can enter into the quiz. I will enable that. Okay.